Okay, welcome back everybody. Today we're going to look at adding and subtracting rational expressions. Alright, so let's start with a numerical example as usual. Okay, well, suppose I ask you to add 1/2 plus 1/3. Well, as you probably recall, we need to build a common denominator here. Okay, so what is my common denominator here? Well, we want to get the smallest common denominator, or the least common denominator. And for this expression here, the least common denominator, well, we want to find the least common multiple of 2 and 3. And so just like in the last video, we just want to take the highest exponent appearing on any prime factor. So here, our least common denominator is 2 times 3, which is 6. Okay, so now we want to build up our fractions. We want to make the common denominators. So we're going to multiply the 1/2 by 3/3 to give us the common denominator. And then we need to multiply 1/3 by 2/2 to get the common denominator. Okay, now all together we get this. I can write this as one fraction now. I've got 2 times 3, which is my least common denominator, and then I've got 1 times 3 plus 1 times 2, which of course is just 1 times 3 is 3, 1 times 2 is 2, over 2 times 3, which gives me 5/6. Okay, so I wrote some extra steps here. Most people wouldn't take this many steps to solve this question or to evaluate this, but the pattern is very similar when we're doing it with rational expressions. Okay, so what we're going to do is just jump into a few easy examples, and then we'll talk about the steps that need to be taken when simplifying a rational expression, when adding and subtracting them. Okay, so first let's give this a shot. Okay, let's add 3/x plus 2 plus 2 over x plus 1. Alright, well, what we need to do is build a common denominator, and this was the purpose of the last video. We want to find the least common multiple of x plus 2 and x plus 1. And if you remember the last video, I said, okay, well, we just take the highest power appearing on any given factor. So here, our least common denominator, or the least common multiple of the denominators, is just x plus 2 times x plus 1. And we're doing this because we want to have the same denominators. Okay, so now we're just going to build these fractions up. So we get this. I've got 3 over x plus 2. And I'm going to need to multiply this by x plus 1 over x plus 1 to get this common denominator. And then I've got plus 2 over x plus 1, but I can't quite add these two things together yet, because they don't have the same denominator. So what I'm going to do, I'm just going to multiply the top and bottom of this one to get the common denominator. I'm going to multiply the top and bottom of it by x plus 2. Like so. Okay, now, well, if we look at this example here, this next step here is going to be the same as this step here. We want to write it as a single fraction. Okay, so I've got x plus 1 times x plus 2. That's my common denominator. And then the top, well, here I had 1 times 3. Here I've got 3 times x plus 1. And here I had 1 times 2. Here I've got 2 times x plus 2. Don't forget to do the plus 2 times x plus 2. And if you look at this step here, well, we basically just simplified. We did the multiplication to get 3 and 2, and then we added them together. So same thing here, except we're working with a polynomial. So we just want to expand, expand, and collect like terms. And so I need to use the distributive property here, and the distributive property here. And this gives me 3x plus 3 plus 2x plus 4 and this is all over x plus 1 times x plus 2. And if I continue to collect here, I end up with 3x plus 2x is 5x, 3 plus 4 is 7, and this is all over x plus 1 times x plus 2. Okay, now at this point we have a rational expression. Okay, just a single fraction here. And the purpose of the second video was we said, okay, well, we want to simplify these things. So if I could factor this numerator, I would. And then I would see if there are any common factors to cancel. Okay, but all that's left at this point is to list the domain restrictions. And again, we don't want division by 0. So we just have to exclude these two values. X cannot equal minus 1, and x cannot equal minus 2. X cannot equal minus 1 and minus 2. Good. Okay, I hope that went smoothly. So let's move on to an example of subtracting rational expressions. All right, let's subtract 2 over x plus 5 minus 5 over x minus 5. Okay, so the first thing we're going to do is just state the least common denominator, the LCD. And we're going to use a little trick here. The reason we're writing this is because I'm just going to write LCD all the way through. So I've got an LCD of x plus 5 times x minus 5. All right, I'm going to need to multiply the top and bottom of this by x plus 5. I'm going to need to multiply the top and bottom of this by x minus 5 to get this common denominator. So what does that give us? Well, we've got 2 over x plus 5. I need to multiply the top and bottom of this by x minus 5 to get the common denominator. And then I'm subtracting 5 over x minus 5. And I need to multiply the top and bottom of this by x plus 5 over x plus 5 to get the common denominator. Okay, so this is a fairly important step here. The reason we write this step out, or the reason I write this step out, okay, is because students often miss this negative sign. So this negative sign is attached to the minus 5, and in this step, when we form our single fraction, we would end up with 2 times x minus 5, and then I need to minus 5 times x plus 5. Okay, so don't lose the minus sign here, guys. It's very important to not lose that. We need to distribute the negative 5 through the brackets here, and then collect like terms. Okay, now, rather than writing x plus 5 times x minus 5 over and over, I've already stated what the least common denominator is, so I'm just going to write LCD here to save myself some writing, and then we'll replace that with the actual factors at the very end. Okay, now we need to expand and collect like terms. So I need to distribute the 2, distribute the minus 5, and that gives me 2x minus 10, and I get minus 5x minus 25. And this is all over our LCD. Now if we collect our like terms, 2x minus 5x is minus 3x. Minus 10 minus 25 is minus 35. And this is all over x plus 5 times x minus 5. That was our LCD. And maybe I would simplify it at this point just by pulling out a minus sign. So I've got minus 3x minus 35 over x plus 5 times x minus 5. Okay. Let me just check my work here. I'm wondering if I made an error here somewhere. I lifted this off the internet, to be perfectly honest. And I thought we were going to have some extra factoring at the end to cancel common factors. Minus 5x minus 25. I think I'm okay here. Okay, so let's just list our domain restrictions. For these questions, you can basically just look at the LCD. Okay, that's our common denominator. So our domain restrictions here are just x cannot equal minus 5, x cannot equal plus 5. Okay, good. So let's talk about, in general, how to do these questions. Let's write you a little summary here. Okay, so to add and subtract rational expressions, we're going to 1. We need to factor the denominators. And build a least common denominator. Two, we're going to build up the fractions. In other words, we're going to make the common denominator. Three, we're going to simplify the numerator. And we're going to expand and collect like terms. And then 4, we're going to factor the numerator again. Or not again, for the first time. Okay, we're going to factor the numerator and cancel common factors. And let's just throw this in here. And state domain restrictions. Okay, good. All right, let's see. If you want to crack your textbook open here and just work directly in your textbook, I'm going to do the U-try on page 296. Okay. Of course, you can just continue to write notes here if that's what you're doing. And I imagine I'm going to need quite a bit of space to do this question. Okay, so let's just separate this paper. Start with a fresh piece of paper. Terrible for the environment, but it's so nice to have a fresh piece of paper to do math on. All right, so this is the U-try on page 296. This one's going to be a bit more complicated than what we've done so far. Okay, we're asked to perform the indicated operation. Well, we're going to add and subtract some rational expressions together. Okay, so we want to do 6 over 2a plus 4a squared plus 3 over 2a plus 1. And then we want to subtract a squared minus 1 divided by 2a squared plus a. Okay, so the first thing we need to do here is just factor all the denominators. Okay, so this one's pretty straightforward. Okay, the first thing I'm going to do is just factor the denominators. So what do I get for this one? Well, here I've got a GCF of 2a, so I'm just going to factor that out. And this leaves me with 1 plus 2a. Okay, now I'm going to rewrite this as 2a plus 1. 1 plus 2 is the same as 2 plus 1. So this gives us 2 times a times 2a plus 1. Okay, this one is already factored for us. It's just 2a plus 1. And this one just has a common factor of a. So I'm going to factor out an a, and that leaves me with 2a plus 1. Okay, now we need to build our least common denominator. So let's just write out our factored form, well, what do we have? We've got 6 over 2a times 2a plus 1 plus 3 over 2a plus 1 minus a squared minus 1 over a times 2a plus 1. Okay, so we need to state our LCD here. You know, you can do it just by saying to yourself, okay, well, I need all of these to match. Well, what would I have to do here? Perhaps you can see that all three of these denominators have the 2a plus 1 in common. Okay, and then this one has a 2a, while this one just has an a, and this one has neither. So what would I need to do to get these to match? Well, I would need to multiply this one by 2 to give me 2a times 2a plus 1, and I'd need to multiply this one by 2a to match. Okay, so what do we get as an LCD? We get 2, because I've got a factor of 2 here, none there, and we need to take the highest exponent appearing on any given factor, and then I've got an a to the power of 1, so the highest power of a is a to the power of 1, and then I've got a 2a plus 1 to the power of 1. That's the highest power of that factor. So that's my LCD. Okay, now we're going to build up our fractions. This one already has the common denominator, so it's okay as it is. This one is missing the 2a. So we're going to have to multiply the top and bottom of this by 2a, like so. Okay, now last but not least, got minus a squared minus 1 over a times 2a plus 1. This one needs to be multiplied by 2. So we'll multiply the top and bottom by 2 over 2 like so. Okay, now let's just write it as a single fraction so we don't make any mistakes, any sign errors. I'm just going to write, for my common denominator here, I'm just going to write LCD. They've all got the LCD at this point. And then I've got 6 plus 3 times 2a and I move this 2 to the front because, again, 3 times 2 is the same as 2 times 3, so I can just move the 2 to the front. So I've got minus, don't lose that minus sign, I've got minus 2 times a squared minus 1. So there's an implied set of brackets there. Okay, good. So, you know, the hard part's done, I think, at this point. All we need to do now is just expand and collect like terms, which gives us this. Well, I've got 6 plus 6a. And then if I distribute the negative 2, I get minus 2a squared plus 2. That's if I distribute this. And this is all over LCD. And now if I collect my like terms, I believe I get this. I get minus 2a squared plus 6a plus 8 over LCD. We're running out of space here, and now we need to factor the numerator. Okay, I mean, right now we just have a rational expression, and the way to simplify a rational expression is just to factor and cancel common factors. Okay, so if I factor the numerator here, the first thing I'm going to do is pull out a minus 2. So I've got a GCF of minus 2 here, and that leaves me with a squared minus 3a minus 4. And this is over our LCD. Trying to squeeze this all in on this one page. See, these questions require a lot of work. It's not difficult work, but it's a lot of writing. Okay, now if I factor this, it's a trinomial. It's the simple type, where if I can find the factors of c that add to my b value, I can just use those to factor it. So what factors of minus 4 add to minus 3? What multiplies to minus 4 and adds to minus 3? Well, hopefully you can see it's just minus 4 times 1. Minus 4 plus 1, like so. Okay, so therefore this factorization of this is a minus 4 times a plus 1. Okay, now I'm just going to write my LCD here. I'm going to use this LCD and replace it. What do I get? I get 2 times a times 2a plus 1. And now we can cancel a factor of 2. And we're just left with minus, I'm just going to write that at the front, a minus 4 times a plus 1 over a times 2a plus 1. Okay, now for domain restrictions, again, we can just look at the LCD here. In this case, I can see if a equals 0 by the zero product property. If a equals 0, this expression will equal 0. And if a equals, well, what's a going to equal here? Remember, if I set this factor equal to 0, it's going to be a linear equation. And the first thing I would do to isolate a would just be to subtract 1 from both sides, and then I would divide by 2. Okay, so for domain restrictions, I have to say a cannot be equal to 0, and a cannot be equal to minus 1/2. Right, if I set that equal to 0, or that equal to 0 for that matter, I would get 2a plus 1 equals 0, and then I would subtract 1, which would give me 2a equals minus 1, and then I would divide by 2, which gives me a cannot equal minus 1/2. Good. Okay, what I'm going to do is stop this video now, and then I'm going to do another example on the next video. So let's call this, I'll call this lecture, I think it's lecture 5.0, and then 5.5 will be another U-try. It will be the U-try from page 298. Okay, bye for now.